Okay, you were asked to, using mechanistic steps, describe the reaction of phenylaldehyde with 2,4-dinitrophenylhydrazine. So, phenylaldehyde, you need to know that phenylaldehyde is just a collective name for all compounds containing the phenyl. They could be the aldehyde, but they should contain the phenyl, which is basically this. All right, so you need to choose which of the phenylaldehyde you want to react or show the mechanism with 2,4-dinitrophenylhydrazine. So in this case, I'm going to be selecting benzaldehyde. Benzaldehyde is written this way: COO, is an aldehyde. This is the aldehyde group. Then you have a benzene. All right, so this is benzaldehyde. You can work with benzaldehyde because it's a type of phenylaldehyde because it contains the phenyl. You can see the phenyl here. So this is also a phenylaldehyde, benzaldehyde. So that's why we're going to be working with it. So basically we're going to be reacting it with 2,4-dinitrophenylhydrazine. Hydrazine has the molecular structure that looks like this. H2N, you can have the nitrogen, right? Then you can have an H now bonded to the benzene ring. So I've written it in red to show you that's the hydrazine part of the compound. So on this is 1, this is 2. So on the second we are going to have a nitro. It's 2,4 dinitrophenylhydrazine. So we're going to have NO2 here. This is 2, right? This is 3, this is 4, this is 4 now. So I'm going to put another nitrogen, NO2, another nitro group there. So this is 2,4-dinitrophenylhydrazine. This is 1, this is 2, this is 3, and this is 4. So that is 2, 4, right? So now that we have our phenylaldehyde, which is benzaldehyde, we have the 2,4-dinitrophenylhydrazine. Then this is where we can now show what happens if they react. All right, so we're going to show the reaction mechanism. That's what it basically means. Now in the previous video where I've explained where or why we have all this, that's to tell you we are supposed to have non-bonding electrons here, 2 of them on nitrogen. Okay, I've explained that in the previous video, so you should know why we have those dots there. So let me write this one. Okay, it's just a minute. All right, so if you're not conversant with these non-bonding electrons, you should watch the previous video. So nitrogen basically should be surrounded by 5 electrons, meaning nitrogen is atomic number is 7, right? So if we have 1s2, then we have 2s2, that means we should have 2p3, right? 3 plus 2 plus 2 is 7. So these are the valence shell, which is 5. 3 plus 2 is 5. So that means nitrogen is always surrounded by 1, 2, 3, 4, and 5, like that. So do you understand? So that's basically it. So this is 1 here. This is 1. This is 2. This is 3. And we have this 2, making 5. All right. So that is that. So with that being said, now we know why nitrogen is surrounded by 5 and why we have those electrons here, right? So let's proceed to showing the mechanistic steps. Now, if you look at the 2,4-dinitrophenylhydrazine, we have one nitrogen here, we have another nitrogen here. Now, the nitrogen that is going to go into reaction is this one. And why it is this one is because it is less hindered. So it's found at the outer side. So it is not under the influence of steric hindrance. So nitrogen is very much hindered. This B is very much hindered. And as you can see, these non-bonding electrons are not readily available because they are far away from, the other one. So this nitrogen here is more closer to reacting than the one inside. All right. So, and the one inside, which is this one, is less reactive, while this one is more reactive. All right. So with that being said, that should explain why we are going to start with this nitrogen. This is the reaction. This is the nitrogen that is very reactive. All right. Its lone number on bonding electrons is more available for reaction. Okay. It's more nucleophilic than this nitrogen. All right. So that is the explanation I can give you there. So let's proceed. And if you look at this carbon here, this carbon is very much positive because it's directly under the influence of so many withdrawing groups. You can see oxygen is directly attached to oxygen, right? So here is delta positive, here is delta negative. So if this nucleophile here is going to react, it's going to attack the carbon here that is positive because it's more electron deficient. Okay, so what I'm going to do is, let me clean this. Just illustrated that so that I'll just explain why the nitrogen here is going to attack. So it's going to attack the carbon here, these electrons. So it's going to attack. And you know, when it does, what it means is that these two electrons over here, these two electrons, is going to form a bond to that carbon. Like I said in the previous video, 2 electrons stands for 1 bond, right? So that's what is going to happen. So, and if it does form a bond, remember that carbon is supposed to be surrounded by 4. You know, it can coordinate 4 atoms for carbon like that. So if this is going to form, this particular one is going to form a bond now, that means carbon will be surrounded by 5 bonds, which is not possible. So this is, you can see we have 1, we have 2, we have 3, we have 4. So if this one should come, it's going to make 5. So that will lead to the drifts of this pi bond over to oxygen. All right, 1 bond will leave to balance carbon, which is always 4. And don't forget that oxygen is surrounded by 2, like this. All right, so this is basically the first thing that is going to happen. I believe this is clear enough. Let me clean this. So this is what is going to happen in the first stage. All right, so the nucleophile is going to attack the carbon of the carbonyl compound in the benzaldehyde, which is a phenylaldehyde. So when that happens, what we're going to have next, let me try to see if I can squeeze it right here. All right, remember that let me show you. Remember that nitrogen is forming a direct bond to carbon, and the pi bond and its electron is drifting to oxygen, meaning that oxygen is going to be negatively charged, is going to have a lot of electrons. So I'm going to now write, show this diagram again. Let me see if this place can contain it. And another thing I forgot to mention is that this reaction is taking place in an aqueous medium. Aqueous medium meaning presence of water, and in the presence of an acid. So we're going to represent that by H3O plus, which is hydrazonium ion or hydronium ion, and the ozonium ion. Then in the presence of water, that is what will drive this reaction. Okay, so the water is going to serve to facilitate the process. You know, it's going to help to stabilize the intermediate that is going to be formed. That is what this water is going to do. While the acid here, okay, is going to provide protons, and we need protons. You know, acid donates protons, so protons in form of H plus, right? So we are presenting the acid with the ozonium ion. You can see here, this is the ozonium ion. All right, so that's what we need for this reaction to, you know, move forward. With that being said, so we're going to have, let me see if I can squeeze that in. So I'm going to just draw the whole of this structure to show how this bond from the nitrogen, right, is coordinating to the carbon. that's basically what I'm going to show. So just watch closely. I'm going to start drawing from here. Yeah, from here you can see. So that's what I'm going to start drawing. So I'm going to have hydrogen, right? Then I have carbon. Okay, now I have one bond, right? Because you remember this arrow here, that bond, all of its electron is going. So I'm going to have just one bond with an oxygen. So the bonding electrons, this arrow, each bond is 2 dots. Remember? So I'm going to have the 2 dots from the red arrow, right? We had initially the other one, and we had initially the other one. So what this basically means is that the whole of this, I can represent this by negative, right? So let me clean this up. So it's going to look like this. So oxygen is going to be a negative sign, right? To tell you that there are a lot of electrons there. So then we have, coming downward, we have bond here. Then we have the benzene ring. This time around, I'm just going to represent it this way. You can choose to represent it this way, all right, for convenience, because there's no delocalization. So once I have that, remember this nitrogen over here is coordinating with the carbon here. So what I'm going to do is, let me wipe here off. Let me start from here and make it more, clear enough. So let's have it drawn here. So if you have your paper, you should be looking at it. So already, okay, I can see what is there. Let me now put it here. So let me start with, remember we have an oxygen, right? We have an oxygen that is negatively charged with non-bonding electrons like that, coordinated to a carbon, as you can see here, right? Then we have hydrogen. So I can put the hydrogen here and put the hydrogen here, all right? Then we have the ring, which I said we can represent it this way. Then we have oxygen, we've added that. So what's left is the bond from carbon to the nitrogen in the phenylhydrazine. So I'm going to have this drawn this way, right? Then I put the nitrogen. Now when that happens, when that bond takes place, you get to notice something. Remember we have 2 hydrogens. You can see 2 hydrogens here. So I'm going to represent the 2 hydrogens here like that. My nitrogen looks too big. Let's make it smaller. This is nitrogen with those 2 hydrogens. All right. Now look closely. Now that we've represented the nitrogen and the 2 hydrogen, there's a bond to this nitrogen, right? So that bond, let me put it here, to the nitrogen. And the nitrogen has 2 non-bonding electrons with hydrogen. So I'm going to put the 2 nitrogen non-bonding electrons here with the hydrogen, then attached to this ring. Okay, so I'm going to have this attached to the ring. All right, but there's an NO2 here and there's NO2 there. Can you see? So but look closely at this nitrogen. Remember what I said at the beginning of this video, nitrogen should be surrounded by 5, but if you look closely, it's surrounded by 1, 2, 3, and 4, meaning that it's deficient. Okay, so in that regard, that's to tell you that nitrogen is deficient, so we're going to have a positive charge here. See, nitrogen is going to be a positive charge. You see, oxygen is bearing a negative charge. Can you see? So once you got to this stage, yeah, you're going somewhere. Yeah. So now I can have this arrow. Let's do something here. Let's do something here. So let me show the arrow this way. This is what is happening. So remember the acid and water. All right. Sorry. Let's write it this way: H3O plus and H2O. And you know, oxygen what has this, right? For water, we have two lone pairs of electron like that, and that is water, right? So in this case, what is going to happen? You see this nitrogen, this hydrogen, I mean, nitrogen itself would need to stabilize. Okay, what will happen is the electrons from the oxygen here, water is going to pick up the hydrogen, is going to pick it up. So when it picks it up, it's picking up just this hydrogen. So when it picks it up, because nitrogen is going to withdraw these bonding electrons to itself. Can you see? So when nitrogen withdraws the bonding electrons of hydrogen to itself, okay, to stabilize this charge, then we are going to have this nucleophile here picking up the hydrogen. So when this happens, what we are going to get is what I'm going to draw here. All right, I hope this is understood. So what is going to happen is that we are not going to draw this again, and let's draw it now. Let me see. Let's start with here from this region. So I have oxygen, trying to maximize the space I'm using. So I have oxygen, then I have those electrons, these ones. I have this one, I have a negative charge, right? Then I have it to the carbon, as you can see here. So I have carbon, I have this hydrogen, this one, there's hydrogen here. So I'm going to have hydrogen, right? Then downwards I have the ring, as you can see. I have the ring, then this bond to nitrogen, this bond to nitrogen. Now remember that nitrogen has withdrawn the bonding electrons, and the bonding electron stands for this. Can you see? See, I've just represented that. The bonding electrons that have been withdrawn from the hydrogen, right? So, and you know, we originally have this hydrogen here, right? So I'm going to indicate that here, that hydrogen over there. And then moving forward, you have a bond down below. So I'm going to put that bond here, which is coordinated to nitrogen, as you can see here. Then I'm going to include those dots. Remember, non-bonding electrons. Then we have hydrogen over here. So that's what I'm going to put here. So let me just put it here. Then moving forward again, down below we have this ring. So we have this ring, right, with the nitro groups. Can you see? So this is what we have. You see? Now that hydrogen that has been removed is going to form yet another proton. All right, it has gone. All right, so hydrogen has been removed. So we have this now. Now what is going to happen is water has played its role in helping to stabilize the intermediate. This is the intermediate. It's stabilizing the positive charge. As you can see here, stabilized. So that is the role of water, like I said in the initial stage. So next thing, since water has played its role, now the acid, which is this one, is going to play its role. This one, this reagent, is going to play its role. Now its role, let's proceed. So let me open up this so that you understand what is going to happen. That's H3O plus, that's the acid. Oh shit, just a minute. Have H. oxygen, hydrogen, hydrogen, hydrogen. So I'm only representing H3O plus, right? So I have a positive charge on the oxygen, right? So what will happen is this oxygen, this particular oxygen here is electron rich. So it's going to pick up a proton. It's going to pick up this proton. So what it's going to do, because that's the essence of the acid is to provide protons, right? So what will happen is it's going to pick up the proton, right? And as it's picking it up, it's actually picking it up because oxygen, this oxygen is going to withdraw the bonding electron, this bonding electron, right? So what will happen is oxygen is withdrawing the bonding electron to itself. Can you see? And if it does that, definitely this is going to be H2O. This is H2O. See, water will be formed again. So oxygen is picking up the hydrogen from the acid. All right. So now we're going to draw what it's going to look like when it does pick up this hydrogen. All right. So that is what I'm going to draw next. So let's have an arrow showing the next structure we're going to have. Basically, I'm going to show all of this with a bond to hydrogen. That's basically the difference. Okay, so don't forget. So let me just, okay, I can see what is there. So if you were to paper, you should be looking at it to follow up exactly what I'm doing. So we have hydrogen, right? This hydrogen now is this hydrogen, right? So I have hydrogen, then with an oxygen here. This oxygen now, that's what I'm going to draw. So I'm going to have oxygen with these two non-bonding electrons. As you can see, these two non-bonding electrons, this is also two non-bonding electrons, so coordinated to this carbon, right? Connected to this carbon, and that carbon has nitrogen, hydrogen, and all of that. So I'm going to have this carbon bearing this way hydrogen, that way nitrogen. That nitrogen has non-bonding electrons too with hydrogen, as you can see here, this one, right? Then look at it, this one particularly, then a single bond to this nitrogen with a hydrogen. So I have a single bond to the nitrogen, right, with a hydrogen, right, with this non-bonding electron again, as you can see here. Then another one to the ring, which we've drawn previously. So I have NO2, then I have NO2. Can you see? So this is essentially what we are having. All right. So this basically has formed water, meaning that water is removed. So you can just write here minus H2O. All right, because water has been removed. All right. So that's basically that. So once we've gotten to this stage, yet again, if you look closely, all right, essentially what we want to do is to remove all the water molecules. All right. So another thing is going to happen is have an arrow. The acid, yet again, can donate proton to this OH, because if we get some hydrogen here again, we are going to, if we get some hydrogen here again, we are going to essentially remove water, because water is H2O, so we have OH. If it picks up another hydrogen, water is gone. So you see, so we are going to have H3O plus coming up again. That's the role of the acid, providing protons. Okay, so to illustrate that, let me come over to this side and just show the same thing we showed earlier. Oxygen, hydrogen, right? Hydrogen, this is plus, right? So, and you know what's going to happen? So oxygen is going to withdraw its bonding electrons again to itself, right? Then this oxygen will pick up the hydrogen. All right. See, that means water is formed again. So water is formed again. All right. So let's see. That's the action of H3O plus. Let's see. Let's clean this place off. Let's clean this place off. So we're adding H3O plus here because this is H3O plus. So now when this happens, you can see the oxygen here is picking another hydrogen. Can you see? So I'm going to write it again, just the whole of these structures, just showing that these two non-bonding electron is forming a bond with this hydrogen. That's just going to be the difference. So I'll start with hydrogen here. So let's have hydrogen, right? Then we have bond to oxygen, non-bonding electron here. Now these two non-bonding electron you see here, these two is forming a bond with another hydrogen, the new one. Then you can now show all these ones: carbon, hydrogen, this is nitrogen, it's these bonds. Then you have hydrogen here. Remember, this is nitrogen, right? This is nitrogen, and this is those two electrons. So once we have this, then you can check the bond here. We're going to have, where is it? We have where is it? We have this, right? We're not going to show this one, right? So let's continue. So we're going to have a bond coming down here to nitrogen, all right? Then hydrogen, before we have the benzene ring with NO2. So as you can see, this is what we're having. Okay, so at this stage, if you look closely at this area, you see that we can remove water. And in that case, to remove water, oxygen is more electronegative than carbon, so it's going to withdraw the bonding electrons to itself in order to remove water, like this. So when this is done, all right, when this is done, water is removed. All right, and when water is removed, let's show that in the next slide. We need to show what is happening here, right? We need to show what happens when oxygen withdraws the bonding electrons, these bonding electrons to itself. So what happens is that carbon will be positively charged. We all know that. So that's what I'm going to represent in the next slide to show the new structure where carbon is positively charged, where water has been removed. So now I'm going to show that here. Now that water has been removed, we'll continue from there. Minus water, right? So we now have carbon that is positively charged. Remember, closely look at the one you've been following me up with. There's hydrogen here, then there's nitrogen, yeah, nitrogen with all of this, right? So we have that. I'm going to write that here. Nitrogen has this numbered electron. Remember, it has hydrogen at the top. Then coming down, we have another nitrogen with hydrogen here. Then before we have the ring with NO2 groups, right? NO2 groups. So basically, usually if you are writing this, you need to always show the nitrogen clearly. So now if you look closely, we've generated a positive charge on the carbon, but this has to stabilize. And for this to proceed, For the reaction to proceed, sorry, let me make this more clearer here for easy understanding. We have nitrogen, right? So let's have the electrons here, then let's put hydrogen here so that I'll show you what's happening. So what's going to happen now is that the bonding electron, this non-bonding electron here, is going to, nitrogen is going to donate its non-bonding electrons to this bond here. So we're going to have a double bond being created here while this positive charge is stabilized. Okay, so that's what is going to happen in this stage. So we're going to have the next structure. Let me see, let's have it here. We're supposed to have hydrogen, okay, carbon, then the benzene ring, right? Then the positive charge is gone, so we have a double bond here. Then we have nitrogen, then we have that hydrogen you see there, right? Then coming down, we have N, nitrogen, with this hydrogen, then with the ring, all right, NO2, NO2. So now we have this. Remember, nitrogen here is surrounded 1, 2, 3, 4, surrounded by 4. So here is going to be a positive charge. So we're going to have positive charge here. Can you see? So this is what we're going to produce at this stage. So, and if you look closely, we really don't need the positive charge. We need to stabilize it. And the only thing that can stabilize this positive charge, remember, that is why we need the water, right? And the only way it can stabilize it is that nitrogen is going to withdraw the electrons, forming a bond to hydrogen to itself, all right? And then we will now have water that will pick up this hydrogen, all right? And when it picks it up, you know, it goes out. So then we are now going to have this nitrogen being stabilized. So the final product now will look like this. In the long run, our final product is this. I'm going to draw this again without the hydrogen, and you know we are going to have two non-bonding electrons on the nitrogen to balance. So we're going to have hydrogen, carbon with the ring, right? Then with the double bond, nitrogen, remember the bonding electrons now, look at it here, the one that we gotten from the hydrogen, right? So we have single bond, then nitrogen, non-bonding electron on this one, talking about this stage, right? So then we have hydrogen here, right? Then coming down, we now have the nitro group with NO2, then with NO2. So you see, if you look closely, everything is balanced. Carbon here is surrounded by, this carbon here is surrounded by 4, so it's okay. Nitrogen 5, nitrogen here 5. So this is our final product, okay? So basically, this is how you show the mechanistic steps for this reaction. So this is what you're going to get. This is the final product, and this is where you stop. All right. So this is how you show the mechanistic steps that describe the reaction of a phenyl aldehyde. We started from here. All right. We proceeded to this section where we had to remove water. So we finished up.